Good morning, dear viewers. Today we are going to see about the topic the wind turbine. Wind turbine, in general, comes under renewable energy sources. What are renewable energy sources? The energy source which can never be depleted comes under renewable energy sources. We may be already aware that the solar energy is the most popular renewable energy source. The wind energy, in one sense, we can say, is a modified form of solar energy because wind is generally created by the pressure differences in particular zones of the atmosphere, which is facilitated by the sun's change in temperature. Hence, we can also say that the wind energy is also a modified form of solar energy, and this wind energy comes under renewable source. In today's energy scenario, we very well know that we are heading towards a mass depletion of non-renewable sources like coal, petroleum, oil, natural gases, and so on. Hence, we are forced to move towards renewable sources of energy. So, this renewable sources of energy, the majority comes under solar power. We can see today so many initiatives are being taken by the central government and the state government of India. Not only in India, throughout the world, we can see that there is a rapid push in the direction towards the renewable energy as the non-renewable sources are about to dry up soon. Even the coal mines in India are estimated to be there for around 50 years. That's 5 decades. They have the sources which are sufficient only for 5 decades. So after that, we will be forced to move into renewable sources of energy. As a matter of fact, we can see the government pushing along in this direction towards the renewable sources. So let us try to understand something about the wind turbines. We are going to see about the wind turbines basically, and the major classification of the wind turbine are horizontal axis and vertical axis wind turbine. And here we are going to see just the fundamental structure and working of the wind turbine, right? So the horizontal axis machine is the most used today in India, especially. So we are going to take this as an example and we are going to study about this structure. They're almost for a height of about 40 meters. They come for a height of about 40 meters. They are three blade rotor spinning in a vertical plane. This is the general structure of the machines that are being used today for wind turbines. So what the wind turbines basically do is that they convert the kinetic energy of the wind that is present in the wind into the mechanical energy. And this mechanical energy is converted in turn into an electrical energy. And how do we do that? The generator. That is the most common thing that we discuss in electrical engineering. And all electrical engineers will be aware of this generator, the working of a generator. What is its main role? It converts the mechanical energy into electrical energy, right? So coming to the main parts of this wind turbine. So here we can see the structure, the front dome on which it is called, mentioned as a rotor, and we have blades, and we have the generators which are connected to the gearbox, and we have a brake mechanisms to reduce the speed, a yaw drive and the motor, and we have an anemometer to find the wind direction, and so on. Okay, so this is a basic structure of a wind turbine, and these are the parts. We'll try to break down this, and we'll see one by one what are the functions of these parts here. The nacelle, it's named after the shearing of an aircraft engine. Basically it looks like an aircraft. Okay, that's why the reason the name is derived from the aircraft engine. So it's basically a fiber glass tube arrangement in the form of an aircraft. Okay, and it contains the gearbox, brakes and the generator. So the purpose of the gearbox is to increase and reduce the speed arrangements, and the brakes in case of excess speed, and the generator, as we already discussed, to convert the mechanical energy into electrical energy. One key point to be noticed here is when we go for higher ratings like up to 2 megawatts, the unit transformers, the high voltage unit transformers are also placed in the nacelle itself. And what else is there? It also got the direction and speed sensors. The direction sensor is basically the anemometer, which we have seen in the diagram. The speed sensors has mounted as the back possible on the nacelle to prevent from the dirt coming from the blades. This also acts as a coverage, and it provides a covering to prevent the dirts and the dust particles from entering into the arrangement. The gearbox. So further breaking down, the parts of the wind turbine include the gearbox, the brakes and the generators. So the gearbox here, it increases the RPM to the required level, and it is the most heaviest part of the gearbox. Okay, the brakes are used when the wind is blowing in the critical level to the same turbine. It is mainly to prevent the turbine from the damage due to excess speed. And next comes the generator. It converts the energy of the shaft, basically the mechanical energy which we already discussed, into the electrical energy. And where is this mechanical energy that we are getting it from? It is from the wind. The potential energy stored in the wind is converted into the kinetic energy through the blade or the turbine, and then here we have the generator which converts it into the electrical energy. And then it is further taken to the high voltage transformer, basically a step up transformer, which is going to increase the voltage and make sure that it is ready to be transmitted to the transmission lines. And next comes the tower, the arrangement, the huge arrangement on which the nacelle is mounted. And the height, generally it varies. For example, for a typical 400 to 600 megawatts power, the height may vary from 25 to 45 meters. In general, the dia of the cylinder of the tower is arranged in such a way that it reduces as we go up the tower. So the dia reduces, and the transmission cable from the generator comes down inside this tower. The tower also has the ladder inside with wooden platform at different heights. The ladder would basically helps the operator to go to climb up towards the nacelle in case of service or maintenance whenever it is required. And the platform is called as yaw platform. It's a steel platform on the top tower and it helps the nasal to yaw in the direction of the wind. Okay, this is the yaw platform. So this is a simple explanation to understand the working. Okay, so here we can see the picture. There is a wind that is powering towards the turbine, and the turbine is going to rotate. Okay, and the gearbox here, it's and the gearbox. So the gearbox is going to convert the speed, that is increase the rpm, basically based on the number of teeth. From higher teeth to the lower teeth, the speed gets increased, and which is being coupled to the shaft of the generator. Okay, so here the shaft starts rotating. Okay, from the gearbox gear wheels, the shaft is connected, the generator shaft. Okay, so once the shaft starts rotating of the generator, what is the role of the generator? It converts the mechanical energy into electrical energy, and then it is brought down through the power cables via the tower to the transformer, and the transformer is basically a step up transformer which is going to step up the power, and it is going to send to the transmission line. So we'll see the advantages. R is a free use and it's an inexhaustible fuel. Okay, it's the clean source of energy and it does not pollute the environment. The cost of electricity generation is low, and the lifetime it can be used up to 20 years. Generally, the installation is somewhat costly, but whereas the maintenance cost it's very cheap and it's affordable one. And the wind energy is the fast growing electrical sector as a renewable source. The disadvantages and the problem is the fluctuating pattern of the wind. The wind pattern has to be monitored. The initial setup cost is high, and we have to take care of the bird population in that area, and a feeble noise pollution is also a small disadvantage. It's mainly useful in the areas coastal and hilly areas. Thank you. Thank you for joining for this presentation, and we'll be back with another one in the near future. Please let me know your comments and feedbacks or the topics which you want to know in the comment section. Thank you.